Arrived in New York City. The ultimate in luxurious travel, she is also designed to withstand the toughest conditions of the North Atlantic. As week in, week out, she sails the line between Southampton in England and New York in the United States. This is the story of a legend in the making, of a superliner for the 21st century. Queen Mary II is the most powerful transatlantic liner ever to be built. How she came into being is a story of the inspirational vision of a few men and the technical expertise of many more. At 1,132 feet, longer than 36 London buses, and weighing over 150,000 tons, Queen Mary II is the largest passenger liner ever built. She surpasses every other liner in terms of power, generating enough electricity to light a city with a population of 200,000 people. And she pushes the boundaries of technology in the way that no other ocean liner has done before. Queen Mary II is groundbreaking and innovative in both design and engineering. At a cost of $800 million, Queen Mary II is the most expensive liner ever built. And constructing such an ambitious vessel has involved thousands of workers from around the globe.
It's an amazing, amazing ship. The concept of a liner, the concept of space, the concept of size and strength is quite unique in this project, quite different than what we've done in other ships.
Mickey Arison is the head of Carnival Corporation, the cruise company that in 1999 bought out the renowned Cunard Line, but left the Cunard name intact. For Carnival, the Cunard Line had prestige and history, and it was the only company in the world to still run a regular scheduled passenger liner across the North Atlantic. The Queen Elizabeth II, or QE2 as she is known in England, was launched by Cunard in the late 1960s, and more than 3 decades later still sailed the line from the United Kingdom to America. Recognizing the loyal and lucrative following that QE2 enjoyed, Carnival announced that they would carry on the tradition of the Cunard Queens by building her successor, Queen Mary II. Carnival decided that Queen Mary II would be built as a true liner, a unique vessel in an industry dominated by ships designed for pleasure cruising. When faced with rough weather, a cruise ship, for her own protection and the comfort of passengers, can divert to the safety of a port. But a transatlantic liner, while providing the luxury of a cruise ship, must be capable of sailing through gale-force winds and 100-foot waves to keep her North Atlantic schedule. Then, after arriving at her destination, turn around the same day and do it all again.
When you think this huge ship is going to be crossing the North Atlantic for 6 days, totally isolated, it's I think, very nice for the passengers to be able to look out at the boiling sea around them in the comfort of their ship.
For strength, a liner is constructed with steel, twice the thickness of a cruise ship, and consequently costs over 40% more. In 1999, Mickey Arison and Carnival believed that the extreme costs involved would pay off. Even in the age of jet travel, they predicted that a superliner would attract enough customers to enable them to turn a profit in just over 5 years. Where such a ship could be built was the next consideration. In size, Queen Mary II was the equivalent of a ship and a half, covering an area of nearly 3.5 acres. A shipyard was needed that could manage the vast quantities of material that she would require, like 300,000 steel sections weighing in at 52,000 tons, and could also cope with the multi-million-dollar finances involved. As is usual in shipbuilding, apart from a 20% deposit, the shipyard has to finance the cost of the build, not receiving payment until the liner is finished and formally accepted by its new owners. Alstom Chantier de l'Atlantique in Saint-Nazaire on the west coast of France was the shipyard that offered the best financial terms, facilities, and expertise. It is the biggest shipyard in Europe, as well as one of the oldest and most respected. It was here that some of the greatest liners of the 20th century were built, most notably the Normandy, considered by many to be the finest transatlantic liner ever constructed. The marine architect whose job it was to design the new Queen was Stephen Payne, a man who shared Mickey Arison's passion for great ocean liners.
The ship that really kindled my interest in passenger ships was the old Queen Elizabeth. And I often wondered as a young boy what a fantastic thing it would be to actually design and build a ship that would rival that great ship.
In designing Queen Mary II, Stephen Payne drew much of his inspiration from great ships of the past.
I have a personal philosophy that before you can do anything new, you've got to have a perception of what's happened historically before, so that you know what's worked and what hasn't.
Queen Mary II would use the best features of its predecessors with the latest cutting-edge technology. The decision to build Queen Mary II entirely of steel was the main factor in determining her extreme size. The upper decks of Queen Mary II's predecessor, the Queen Elizabeth II, had been made of aluminum to reduce the weight of the superstructure as far as possible. But extra decks made of aluminum create other problems, including expensive maintenance as the aluminum ages. Stephen Payne faced the challenge of balancing the extra cost of a steel liner against revenue from the number of passenger cabins. The answer was to think big.
We very quickly determined that we just couldn't build anything smaller than QE2. It had to be at least her size, if not bigger.
$1.5 million were spent on early model tests. 80,000 detailed plans were drawn up, and over 1 million man-hours were spent bringing Stephen Payne's vision from the drawing board to a point where building of the liner could actually begin. On the 16th of January, 2002, the first sheet of steel was cut. Materials from all over the world began arriving at the shipyard. Traditional liners, up to the time of QE2, were constructed on an inclined slipway, built up from a keel with ribs and steel plating until the form of the hull was complete. This was then dramatically launched onto the water before the main outfitting was started. Today's methods of shipbuilding are very different, employing prefabricated hull sections and cabin modules in order to keep the build time and costs down. The master plan for Queen Mary II is divided into 42 zones built from 94 separate blocks. Step by step, the ship is constructed from these vast modules like a giant three-dimensional jigsaw puzzle. Every week, 12,000 sheets of steel arrive at the chantier. In the shipyard's own workshops and fabrication sheds, this raw material is cut like cloth for a suit by computer. Rolled and curved. Shaped with heat to follow computer-generated templates. And finally, welded into the component parts of the hull and superstructure. the 4th of July, 2002, just 6 months after the first sheet of steel was cut, the first block was laid in the dock. The ceremony is presided over by her captain-designate, Captain Ronald Warwick. Captain Warwick will leave command of the Queen Elizabeth II to take on this role.
So, to the crane driver, I say, this is Captain Warwick speaking. Please lay the first section of my new ship. Thank you.
With a nod to maritime tradition, 2 coins, one French and one English, are placed in the keel. It is a custom dating back to the ancient Greeks, who put gold coins in the bottom of a ship as an offering to Poseidon, god of the sea. The liner begins to grow. Sections are constructed in the fabrication sheds, then lifted, placed, and welded into position. The modular hull is made up of over 300,000 separate components. Holding all this together will take nearly 900 miles of welding. At an early stage, the liner's principal power source, 4 diesel engines made in Finland, have to be installed. Each engine is 41 feet long and weighs 217 tons. And because of their extreme size and weight, the liner's design places them low down in the hull. Getting them into place must start while the hull is being constructed. The logistics involved in building the biggest ship in the world are mind-boggling. A handful of people shoulder the responsibility. Much of the coordinating of the thousands of employees, materials, timetables, and tests is dependent upon contract manager Jean-Remy Villageois.
The final result must be perfect. So really the yard must do everything, their best effort to match the delivery date, no matter what we have. So it's a significant challenge.
On the 1st of December 2002, to make space for the next ship on the Chantier's production line, the now partly completed hull of Queen Mary II is floated gently down to the river end of the dock, so work can continue. The bulbous bow that will be positioned at the prow of the liner beneath the water was manufactured at Gdansk in Poland. The bulb is designed to improve hydrodynamic efficiency by eliminating the bow wave that the liner creates as it moves through the water. The liner's massive bow structure with its distinctive, elegant flare towers almost 100 feet above the waterline.
On Queen Mary II, I've tried to take elements from all other successful ships, elements that I felt really would work well combined into one great liner. If you take the bow of the ship, it's actually based on that on the QE2, where she was crossing the Atlantic for over 30 years without major damage. It seemed logical to repeat that. And atop that, I've put the breakwater of the Normandy that was very efficient in dispersing any seas that went on the forecastle in rough weather.
Queen Mary II's navigation bridge, or wheelhouse, is huge. At almost 150 feet wide, it is designed to house her up-to-the-minute integrated computer systems. The bridge was inspired by Queen Elizabeth II, but where she has open bridge wings, on Queen Mary II it was felt they needed to be fully enclosed to protect the sensitive electronic navigation equipment. Another enormous component is the liner's signature red and black funnel.
That's a very important feature of the ship, and it really is the first thing you focus on when you look at a passenger liner. But it also has to be extremely functional. It's there to disperse the smoke and to ensure that no smuts or gases fall on the surrounding decks. And it was a real challenge to develop a funnel within the height restrictions we have.
When Queen Mary II arrives at New York, she will have to pass under the Verrazano Narrows Bridge.
QE2, when she enters New York Harbor, she has 12 meters clearance to get under the Verrazano Narrows Bridge. Queen Mary II is so much higher that even with this funnel, they will only have 2 meters clearance. And the real problem we had was to develop this funnel in such a way that the smoke would disperse from the top of it without going on the aft end of the ship. And we achieved that by optimizing the shape of this scoop. And when we first tested the funnel without the modified scoop, it didn't work particularly well. But optimizing the funnel in the wind tunnel and making the scoop work as it should, we now have a very good funnel, especially considering the height. The shape of the ship is classical because when you look at it from the side, it's like a pyramid. The funnel is in the middle of the ship, and that's where the heaviest part of the ship is, where the engines are. But the forward end and the aft end needs to be lighter, and that's why you have the pyramid shape, where there's not much right at the front of the ship, not much at the back. And the whole thing is just completely different to the box that you see as a modern-day cruise ship.
Thanks to her modular structure, the speed at which the build progresses is incredible. Just 13 months after the first sheet of steel was cut, exterior construction is nearing completion, and Queen Mary II is almost ready to be floated out. She'll be moving from the dry dock to sea dock, where she will be fitted out. This dock has lain empty since the last supertankers were built here in the 1970s. But because of Queen Mary II's extreme size, it is the only one that will accommodate her. Preparing the dock takes several months of work, clearing it out and laying the blocks that will be used to support the liner. Underneath these blocks, there are over 6 feet of reinforced concrete. This, together with the metal beams with their top cushion of wood, will provide the support for the gigantic liner to rest on. In the past, the launch of an ocean liner was a very tense and dramatic moment. If the calculations were wrong, she could either come to a halt on the slipway or slide out of control down to the water. In 1934, the launch of the first Queen Mary went relatively smoothly, with 2,350 tons of drag chains successfully slowing her down.
Great waters spread friendship.
But when her great rival, the French liner Normandy, was launched 2 years earlier, things had been rather more spectacular. The shipyard had used tons of lard to grease the slipway, and this, combined with what was thought to have been a miscalculation in the amount of drag chains needed, meant that the great ship literally raced into the river at over 20 miles an hour, causing a wave that drenched hundreds of spectators. Even in the 21st century, the float out of the biggest liner in the world is not without risk. Queen Mary II's size means that mishandling this delicate procedure could be disastrous. The depth of the water needed to move her to the new dock will be 30 feet. rocks lie under the water, and the bottom of her hull will have just over 3 feet of clearance. It is March 21st, 2003, the night of the float-out. Though the hull of Queen Mary II is complete, as yet she is a giant, almost empty shell. In the new dock, her transformation into a luxury liner will begin. Queen Mary II has no propellers fitted at this point, so the whole maneuver relies on a flotilla of 8 tugs pulling the great liner along. As dawn breaks, Queen Mary II is successfully positioned into sea dock. Now the fitting out can begin. Teams of people, thousands in number, are responsible for every last detail of the liner. And from the top management to the individual skilled workers, they all make an essential contribution.
I believe that anyone involved, either closely or from afar, will be very proud to have worked on this ship and will hold her close to their hearts, perhaps more than for another ship.
Among the many nations working together on the ship are 350 Indian craftsmen, subcontracted to install the air conditioning.
In India TV channel, we will see with our family that Queen Mary is passing from any country.
I can proudly speak to my children, look at son, this is Queen Mary. I will do work in this Queen Mary 1 year.
Hello, I'm Sophie. I sell coffee on the boat.
Celine works as a welder on the liner.
I can proudly say in 20 or 30 years to my children and grandchildren, I worked on that amazing boat because I believe it's a legend.
The task ahead of all these people is awesome. In only 9 months, they must complete a liner that will house 2,630 passengers and almost 1,250 crew. They're building a floating city, but with fares for the transatlantic voyage ranging from $1,500 to $30,000, it's a luxury that few of them will ever enjoy. At any one time, up to 4,500 people work on the liner, hundreds of different technical trades. Into the body of the liner, the electricians must fit thousands of miles of electrical cable. For fire safety reasons, the owners have specified that the main cables running through the liner must be installed unbroken for their 1,100-foot length. A team of men pull this heavy cable through the twists and turns of the overhead ductwork. Woven in among the electrical cables and wiring are the pipes carrying the various heating systems, air conditioning and water systems, sound and vibration insulation. The numerous public rooms, passenger cabins, and deck areas must be constructed and fitted out. Decorative plaster moldings made for the formal restaurants and theaters. Commissioned artworks designed and produced. Every day, hundreds of new components arrive at the shipyard ready to be fitted. A logistical nightmare unless the planning is perfect. And innovative technical features such as the 4 pods must be installed. Queen Mary II will be the first ever passenger liner to be pulled and steered through the water by 4 pods. huge electric propulsion units suspended below the stern. These pods will be the largest and most powerful ever made. In fact, at 350 tons with all their equipment, each one of the 4 pods weighs more than a fully laden jumbo jet. When the first Queen Mary was built, her ship's propellers weighed only 35 tons each. As the designs for the pods developed, constant testing was carried out. The propulsion tests looked good, but when the pressure pulses were tested, they were disappointing.
What we're doing there, we're measuring the impact pressures on the hull caused as the propellers rotate. And if you have very high pressure pulses, it means that you're going to have very bad vibrations.
The measured levels were over 3 times the specified limit.
So we redesign the pods, move them to a different position in order to have a bigger clearance from the propellers to the hull.
The arrival of the pods and their transportation from the Saint-Nazaire docks to the shipyard gives the local people a glimpse of the enormous equipment needed for the Queen Mary 2. The power is spread evenly over all 4 pods. All the pods have 4-bladed stainless steel propellers. Each blade bolted into position so they can be replaced individually if damaged. The 2 rear pods will be azimuthing. That is, they will steer the liner as well as provide propulsion, like an outboard motor on a small boat. The remaining 2 will be fixed forward, only providing propulsion. Because of their size, getting these propellers into position under the liner is itself a feat of precision engineering. For the shipyard, this is a symbolic moment. The liner now has her own power to move through the water. One of the great benefits of pod propulsion is to reduce vibration caused by the engines. Classic liners, the propeller shaft from the engines passing through the hull of the ship was a constant source of vibration and noise, which greatly affected the comfort of the passengers. On Queen Mary 2, the specification regarding levels of vibration is very strictly laid out. And during the construction, a team is dedicated to the measuring and elimination of noise and vibration. Housed just under the waterline in 10-foot wide tunnels in the bow of the liner are the propellers of the bow thruster units. These electrically powered thrusters enable Queen Mary 2 to maneuver sideways, either when holding position at sea or when docking. At 3.2 megawatts, not only will these be the most powerful bow thrusters in use, but Queen Mary 2 will have 3 of them. Another technical first, as no more than 2 had ever been used on a passenger liner before. Early design tests on the bow thruster openings showed that they increased drag by nearly 3%. Thruster doors would be needed to help eliminate this. Pivoting circular doors, similar to those on Queen Elizabeth II but much larger, were chosen. Another important component is one that will directly affect the comfort of the thousands of people on board the liner. Made in Scotland, the stabilizers have a big job to do keeping Queen Mary 2 steady in the rough seas and storms of the North Atlantic. It is usual for a ship to have 2 stabilizers, but Queen Mary 2 will have 4, each weighing a massive 70 tons. The stabilizer fins will extend nearly 20 feet beyond the liner's sides and react automatically to her roll.
Inside there's a roll sensor to know at every moment what's the roll of the ship. and the sensor processes this information to give instruction to the fins how to tilt, at what speed, what angle.
The stabilizers are designed to react within seconds, and the aim is that they reduce the liner's roll by a projected 90%. But will all these things actually work when they are put to the test? There can be no practice runs with a liner like Queen Mary 2, no prototypes to test. There's only one of her, and the first time they'll know if she works is when she sets out on her initial sea trial just 12 weeks before she is due to be delivered to Cunard. Just before then, a key part of the life-saving system is tested. The lifeboats, which hold up to 150 passengers, are positioned higher than on a cruise ship, on deck 7, over 100 feet above the water.
The new rules and regulations for passenger ships say that the lifeboats must be much lower down in the ship. My argument was, have a look at what happens on QE2. And QE2 in the last 10 years has experienced waves of over 100 feet high. And they have found on occasion that some of the lifeboats have been damaged. And you need your lifeboats. They're there to save you if something really goes wrong. And we spoke with the authorities and they all agreed, yes, you can put the lifeboats up high if you've got a special reason. And everybody said the North Atlantic is the special reason.
One of the most important jobs in the whole build is the application of the paint that protects every square inch of the liner's steel structure. It is specified that Queen Mary 2 should have a 40-year fatigue life. That is, she won't require major maintenance during the next 40 years. In charge of all exterior anti-corrosion painting is Tanya Martin.
Of course, it's a very complete system of paint that we have to apply, more complex than on other ships, more coats of paint, because the owner can't tolerate rust to appear while the cruise is on. And on top of that, really wants a very good quality of details. It must be perfect.
Well, in most parts of the ship, there's an average of 2 or 3 coats. The main structural tanks, we've applied a 1-coat system. We don't want it to be too thick, because if it becomes too thick, it will eventually crack and fall off under its own weight. So there is an optimum thickness.
Throughout the liner, each day, 200 painters set to work. But the conditions must be just right. No exterior painting can be done in the rain, in the moist conditions of early morning or evening. The steel must be treated first with an anti-corrosive paint to combat the rigors of seawater and damp, salty air. In some areas, up to 7 coats are applied. In total, 6 million square feet must be covered. 400 tons of French-made paint.
It's a gauge. It's called a cone. It's used to measure the thickness of the paint which has been put on.
Areas such as the liner's flat bottom, which alone accounts for 24,000 square feet, must be meticulously painted in time for the first sea trials. It must be as smooth as possible, because any roughness here will create drag on the ship as she moves through the water. More drag means loss of speed, up to half a knot, plus additional fuel costs. And from the bottom to the top of the liner, the paint has to withstand extreme temperatures and weather conditions.
The decks will reach 50 degrees centigrade when she's under the hot sun. She will also face the ravages of the North Atlantic, where the waves will stress the ship's structure, twisting and bending the ship, so all of the coatings that we apply have have to be able to withstand those kind of conditions.
The exterior finish under Tanya's supervision can be seen progressing each day. But down in the bowels, below the waterline, is another world where the paint finish is equally important but hidden from view and only reached through small, sealable hatches. Here, teams of painters crawl in the darkness through empty fuel and water tanks and structural compartments, coating behind every bulkhead and into every awkward corner, protecting the hull from the corrosion that could eat the steel away from the inside.
You're always in night. That's the world of the tank painters. It's the night, it's not the day, it's never the day. We are now here in the 5,005th dry tank of the ship, one of the biggest, under the principal engines. The total surface area of the bodywork is a little more than 6,000 square meters.
Painting the liner began in March and continues right up until delivery. Another ambitious aspect of Queen Mary II is her desire to be the first green passenger ship afloat. The idea is that she operates with an environmentally friendly zero-discharge philosophy.
On board the ship, we've got 4,400 people, which is a small town, and as in every town, they're producing wastewater and solid wastes, food wastes. We are not allowed to dump that in the sea. Basically, the main systems are three, yes. We've got the drinking water, which is used for drink of course, but also showers and all usual use. This is one system, hot and cold. Then we've got the so-called grey water system, which is water from galleys and showers and basins, etc., which must not be polluted by water from toilets, which is a third system. So it's three completely different systems which has clearly separated and never be connected.
The wastewater will be purified in a bioreactor back to drinking water standard and used on the ship for activities like deck washing and laundry. Since the float-out in March 2003, the months have moved relentlessly on, and now in July, the liner is only 10 weeks away from its crucial first sea trials at the end of September. The work is progressing steadily on all fronts, day after day, from first light. Come rain or shine, the thousands of skilled workers, managers, engineers, and fitters carry out their jobs. In the steel carcass of the ship, the noise of drilling, cutting, and grinding is deafening, and things don't always go according to plan. The installation of the air conditioning is falling behind schedule. This enormous task entails fitting ducting for hot and cold air throughout the ship. 37.3 miles in all, weighing 800 tons, and estimated to take 500,000 man-hours of work. From the first weeks, the gap between the schedule and the actual fitting has been growing. But Le Queen, as the French affectionately call her, will wait for no man. She must be finished on time. A modern cruise ship is designed from the inside out. A floating hotel encased within a ship. Queen Mary II, however, was conceived first and foremost as a transatlantic liner. She was going to be structure-led, with the interior architects working within these structural arrangements.
We made this deal when we first started working on the project, that I, as the naval architect, would look after the exterior of the ship. But I said to Andy, you leave that alone and you can do the interiors, obviously, and I won't get involved in any shape or form except for the structure, which is very important for this ship.
The block planning of the ship, where the big spaces were going to be, was pretty much developed by Stephen and his team. But we were able to manipulate the actual layouts within those block spaces. We also did help, I think, to instigate some of the flow movements within the ship to be able to give Stephen the benefit of our experience in terms of moving passengers through ships.
The original design brief stipulated a transatlantic liner of modern form that would echo the style and grandeur of the classic liners of the 1930s, the golden era of transatlantic travel. One such grand design is the Britannia restaurant, named after Cunard's first vessel of 1840. This impressive room stretches the full 140-foot width of the liner. With its domed glass ceiling, it is one of the largest public spaces on any ship afloat and will seat over 1,300 diners. As passengers move through these air-conditioned public spaces, they will be constantly reminded of the ocean. There are over 2,500 windows in the hull and superstructure. Everywhere, views out to sea.
A lot of modern-day cruise ships try to be hotels where they try to have the people looking inwards. And it's certainly my intention with this ship that people would be able to look out and be at home on the sea.
One of the places passengers can experience the sea air firsthand is Deck 7, the promenade deck. At this level, over 100 feet above the swell, they can stroll or jog completely around the perimeter of the liner. At the sides, below the lifeboats, and at the stern with its swimming pools and bars, the deck is open to the elements. But at the bridge front, the walkway space is covered in to protect against the Atlantic conditions.
The shape at the front of the ship is based on the shape from the original Queen Mary. And she had a lot of open galleries where people could look out over the front, out to sea. But on a transatlantic run, there's so much wind, it's very difficult for people to stand there and to look out over the sea. So what I did, I took the basic shape and we've plated it in. And in plating it in, you get this marvellous front that is unique on a modern ship.
The end of August, and it is now less than 4 weeks to go before Le Queen's next big test, the first sea trial. In the 5 short months since the successful float-out, she has almost made the transition from a giant hull to an ocean-going liner. Much of the exterior paintwork is completed, and the interior fittings and installation of pipework and cabling is progressing almost to schedule. In every quarter, it's a race against the clock. In the hot and uncomfortable atmosphere of the main engine room, deep in the basement of the liner, the 4 huge diesel engines are being tested. But as with all things, there are teething problems. Prior to running diesel number 4, the engineers have one final check of the oil levels and bearings. And then they're set.
This is only a small piece in a milestone.
But the engine's reluctant to start the first time. There's a problem with the air intake.
I need air to start the engine.
Then she's up and running.
I'm not alone. We are a team.
Now 18 months after construction began, the liner floats gently in the dock, a sleeping giant. The activity around her is as frenetic as ever, but now there is an added air of expectation. For very shortly, she will face her biggest test so far, the first sea trials. The trials are the chance for the shipyard to carry out all the tests they cannot conduct in the dock. And most crucially, to see how Le Queen will behave on the open sea.
There are things we cannot do when we are in the harbor, which we need to do when we are at sea, which is, of course, to try to do max power. We need to do high load on the engines.
Over the next few days, the eyes of the maritime world will be watching. That all will go according to plan is by no means a foregone conclusion. In fact, when the last transatlantic liner in the world, the Queen Elizabeth II, went on her sea trials 30 years ago, the whole experience turned into a nightmare.
Even the expenditure of £29.5 million is no insurance against failure. It was no more than a faulty oil valve in the supply to the main boilers, but it was enough to delay the sea trials and cancel her Christmas cruise.
Queen Elizabeth II limped back to Southampton and a flood of bad publicity. Though unspoken, both Cunard and the shipyard know what is at stake. As the tide rises up to its maximum, there is a window of less than 1 hour in which to get Queen Mary II into the River Loire and then out to sea. Although the liner has been in the river before, when she was transferred to the larger dock for her fitting out. On that occasion, she had no propulsion of her own and was shepherded by a flotilla of tugs. Today, she is going to move under her own power. Tugs will be present, but they're just there as extra security. On this sea trial, the Queen's total propulsion system, her 6 engines, 4 main propulsion pods, and 3 bow thrusters will be heavily monitored. 2 of the 4 pods are wired up to computers so that their azimuthing or steering mechanism and power can be closely scrutinized. Up on the bridge, all the key players are assembled. All the heads of departments, the contract manager, Jean-Remy Villageois, the architect Stephen Payne, and the man who will in a few short months be commanding the liner, Captain Ronald Warwick. The atmosphere is deceptively calm. Everyone is in a state of nervous expectation both here and on the dock, waiting for the optimum moment to start the move. But then there's a hitch. The azimuthing pods were being given a last-minute technical check. By mistake, pod number 4 was rotated a full 360 degrees, tearing out the instrumentation cables connected to the monitoring system. Minutes pass, and with every second, the opportunity to get the liner out of the dock at high tide gets less and less.
The main difficulty was to bring the control back up to the bridge to the captain to be able to maneuver.
After 15 minutes or so, the tension is broken when a call comes through to the bridge. Engineers have managed to reconnect the cables. They're ready to go.
Because we have a very tight window to be able to leave the dock. So if it took too much time to give the control back, then we could have missed this window.
At 5:30 p.m., the pods, with surprising speed, propel the biggest passenger liner in the world out of the dock. As she glides out, the depth gauges show why she had to leave on time. There is barely 3 feet of water beneath her keel. She is maneuvered backwards and with a slight help from the tugs, turns 90 degrees into the middle of the River Loire. Around her, it's a beautiful day. No problems with high winds. In fact, the conditions are perfect. In glittering sunshine, scores of boats dwarfed by the giant Queen escort her, while overhead, helicopters buzz, filming this memorable event.
Well, this is the culmination of 5 years' work, and I think it's a tremendous achievement for the shipyard to have built this ship in the time, and it's obviously a marvellous day. We brought the city to a complete standstill, and words cannot really describe how wonderful it is to be here on the sea trials on this huge ship.
The sun begins to set as the liner sails out of the Loire estuary and into the Atlantic Ocean. But she won't be going far for these first tests. Her destination, the waters around Belle-Île, just off the French coast. Because all the major systems on the liner must be scrutinized under tough working conditions at sea, and the delivery deadline in December is getting ever closer, a very strict timetable of tests must be adhered to. These will be carried out 24 hours a day throughout the 4-day trials. The key people involved will get little sleep. There are 500 people on board for the trials, each with a specific job to do. As well as the work on the bridge, the other nerve center for the operation is situated away from the sunshine, 12 decks below. Here, all the tests are monitored and results processed. There is an interesting duality about the trials. It is the first chance for the shipyard to test the vessel they've constructed. They are very much in charge and want the liner to be seen to be performing to specification. while the future owners, Cunard, are there as observers and on the lookout for anything that's not up to scratch. Everyone will be closely watching the performance of one of Queen Mary II's main technical features, the electrically driven propulsion units, or pods. The pods are a radical departure from the propeller and rudder arrangement of traditional liners. Their job is to both pull and steer the liner through the water. With 20-foot diameter propeller blades and weighing 360 tons each, they're the biggest units ever, producing in total enough thrust to keep 3 jumbo jets flying at 530 miles per hour. 4 pods have never been used to propel a passenger liner before. Historically, pods have been problematic. Out of the 50 or so ships that have been fitted with them, over 75% have experienced difficulties. For the Queen Mary II pods, this is the moment of reckoning. Will they work?
Here we have a 4-pod configuration where 2 azimuthing pods, 2 pods in the aft, which we can steer the ship, operate. And then we have 2 fixed pods, and we can use them just to have more power, more propulsion power, in order to go faster with the ship.
All 4 pods are identical and interchangeable. They will play a key role in many of the tests, and throughout the first night at sea, the engines and generators that power them will be continuously worked and adjusted until they are running at their peak.
We have machinery, which is based on 4 large diesel engine, medium-speed diesel engines, each rated around 16 megawatts electric. And we have 2 gas turbines, each 25 megawatts. We have the diesel engines are installed, of course, traditionally, as always, down in the bottom of the ship. And the gas turbines are installed in the top, just behind the funnel, just behind the exhaust.
Originally designed as an airplane engine and used to power the DC-10, these thoroughbred gas turbines can quickly generate the additional electricity needed to propel the huge liner up to maximum speed. Day 2 dawns, and the weather conditions couldn't be better. There's good visibility, virtually no wind, and the sea is as smooth as glass. At full power, the Queen's hydrodynamic hull cuts cleanly through the water, barely creating a bow wave, thanks to the design of the protruding bulb just below the surface. The maximum speed of around 30 knots seems well within the liner's capability. She is slowly brought to a stop for the next tests of the anchor machinery and the bow thrusters, the propulsion units at the front of the liner, which enable her to maneuver sideways. The 3 bow thruster doors are opened on each side in preparation. Each of these doors is 10 feet in diameter and weighs 3.5 tons. The positioning test begins. The powerful electric thruster motors start up and begin pushing the giant liner sideways. Suddenly, the test is stopped. Something has gone wrong. During the thruster test, one of the massive circular bow doors closed at the wrong moment.
We suddenly heard a big bang, and we then sent the divers to check what happened, and found out that the door was missing.
It appears that a mechanical failure of the hydraulic shutting mechanism meant that door number 3 closed while the propeller was running.
The thruster flow was so strong that it literally cut out the bolt, so it was a real powerful shock.
The broken door sank to the ocean floor. Apart from some internal water penetration around the torn door hinge, the incident does not affect the liner's seaworthiness. The thruster tunnels are designed to be filled with water. The doors are there only as covers to improve the hydrodynamics of the hull. But the shipyard cannot risk the loss of another door, and the bow thruster tests are completely abandoned for these sea trials. how badly the open thruster tunnel affects overall performance is something that will not be fully known until the official speed runs scheduled for the following afternoon. While the liner is stationary, the anchors and the windlass machinery are tested. There are 3 anchors on board, one on each side of the bow and a spare stored below the bridge on the deck. Each anchor weighs 23 tons, and its 1,100-foot chain weighs 5 times that at 119 tons. When lowered, the 2 huge anchors embed themselves in the ocean floor. And this, combined with the lengths of the heavy anchor chain trailing along the sea bottom, are enough to hold the 150,000-ton liner in place. The rate that the anchor chain can be lowered is measured in this test. Pierre Cordier from the shipyard and observers from Cunard gather around the windlass to time the rate of descent.
Okay, stopwatch there. Yeah, we can go.
The noise, as the giant chains are fed through the machinery, is deafening.
C'est bon, un maillon à l'eau. Okay, second shot, attention.
After raising and lowering the anchor several times, the test is successfully signed off, and Queen Mary 2 gets underway again. Information is exchanged constantly, and at mealtimes, the cafeteria becomes a meeting place where engineers and observers from different departments discuss the problems of the day. After the disappointment of the bow thruster door incident, the rest of the day is spent fine-tuning the propulsion system. Apart from the scheduled tests on the Queen Mary's main operating systems, the shipyard managers have a myriad of smaller tests to carry out all over the ship. Jean Roche, who oversees, among other things, the whole water management system on board, finds time in his schedule to test the high-pressure window washing system. This is designed to clean the salt from the fixed windows on the bridge front that are difficult to access. Below the windows, on the enclosed promenade deck, Jean tests the fire sprinkler system.
A fire on the ship is the worst thing. It's what every sailor are fearing. So the systems are very efficient.
Fire has been responsible for the destruction of beautiful liners such as the first Queen Elizabeth. For the sea trials, the ship has been equipped with an extra 300 fire hoses, but these high fog sprinklers tackle fire and smoke in a more sophisticated way.
Formerly, we were really pouring salt water everywhere when you had a fire, so you were just opening a valve and pouring the water in the whole area. Now, the system is based on very high, thin fog of water, and it's just released above the fire by the temperature, and then it's extinguishing by the water effect, as well as like an inert gas by putting the oxygen out of the fire and stopping the fire in that way. That's very efficient, very quick, and it's much safer.
This high-pressure mist system is fitted throughout the fire zones of the ship. By using the minimum of water, it thereby causes the least amount of water damage. As day turns to night, the testing continues. The noise and vibration team have to take advantage of every minute at sea.
When you've got the power that we have, enough power to drive generators for a whole city, it's very difficult to maintain a low level of noise and vibration.
The data that the team collects while the steel structure of the ship is under stress, speeding through the water, is invaluable.
Over these 3 days, it's important that we get all over the ship, because it is our only chance to check the levels at high speed. We often work at night, because there are so many less people walking around the zones which we have to check, so it's much closer to silence, and we can measure the noise of the boat at sea.
This morning we did the stabilizer test. We did it as early as possible before breakfast. to avoid people being seasick or having troubles during their breakfast. And everything went well, actually.
For testing, the conditions at 4 a.m. had been ideal. The sea was calm with only a gentle breeze. The 4 giant stabilizers were used to force the Queen to roll artificially between plus and minus 8 degrees, then timed to see how quickly they could reduce the roll to an acceptable level. Within seconds of the computer setting the stabilizers correctly, the roll was dramatically cut by over 90%. When stabilizers were first fitted to the old Queen Mary in 1953, they not only greatly improved the comfort of passengers on the North Atlantic run, but had the added advantage of saving the owners tens of thousands of dollars in broken china. In an emergency, the ability of a ship to stop or steer herself out of danger is paramount. And with her 2 azimuthine pods, Queen Mary 2 is designed to have the maneuverability of a ship half her size. From the bridge, the orders are given to set a course, sending the Queen at high speed through a series of violent zigzag movements to test the capability of the pods under extreme conditions. Over the next few hours, this zigzag course, followed by the completion of several tight turning circles at full power, confirms the accuracy and speed with which this giant responds to the commander on the bridge.
I think the sea trials of the Queen Mary 2 are going fantastically well. The maneuverability of the ship has exceeded all my expectations.
For Captain Warwick, who is on board as an observer, the sea trials are the first opportunity to see his new liner in action. Ronald Warwick has been with the Cunard Line since 1970 and captained the Queen Elizabeth II for well over a decade. As master of the Queen Mary 2, he will work on a 3-month on, 3-month off rotation schedule. Even with his years of experience at sea, the Queen Mary 2 poses a new challenge for him in terms not only of her sheer size, but also her joystick steering and sophisticated control systems. Captain Warwick and his team spent the past few months in the United States training on a state-of-the-art simulator at the Star Center in Miami, Florida. Here, they've taken the ship through virtual sea maneuvers, familiarized themselves with the procedures for moving in and out of harbor, and tried to get an idea of how she will steer in the changeable conditions at sea.
In the simulator, the ship wasn't steering very well, so we didn't think that that was a true representation, but it was always in the back of our minds that it may be true. But now the ability of the ship to maneuver has proved that the simulator is not totally correct.
With the weather still exceptionally good, the Queen is slowed to 5 knots for the timed launch of the rescue boat from the promenade deck level. At 100 feet above the waves, this is a potentially dangerous procedure, which, if not carried out by the book, could spell disaster for the crew.
First risk is the rescue boat being trapped somewhere and then sort of capsizing or inclined. Then the crew members would simply fall down to the sea. And that's at this height, it could be fatal.
Or if the engines fail as the boat is released onto the water, the whole thing, crew and all, could be dragged under the stern and into the propellers. On the bridge, preparations are already in hand for this afternoon's speed trials, but there is hesitation. Has the loss of the bow thruster door adversely affected the hydrodynamics of the hull? As conditions are good, they decide to go ahead. The timing of the speed test is carried out under the watchful eye of independent observers. 4 runs are made over a measured mile, 2 in each direction to cancel out any advantage that the tide or wind provides. This is an anxious time for the shipbuilders because there are severe financial penalties if the liner does not reach the top speed of 29.35 knots, or roughly 32 miles per hour, as specified. With seemingly no effort, the Queen makes the foreruns at full power. The only noise on the bridge, the loud instructions from the observers timing the liner over the set mile.
Attention pour le start. Attention.
The test is another success, with the Queen Mary 2 turning in an average top speed close to the contract requirement.
When the ship sailed from San Jose on Friday, it just drifted out into the river, and I felt straight away that the ship was going to be very much at home on the ocean where it belongs.
Her first sea trial over, Queen Mary 2 returns to Saint-Nazaire. Though everyone is tired, there is an air of elation on board. The general consensus is that she has outperformed expectations.
There are very, very few things that I would change if I was going to do another one. So that's how happy I am with it.
The liner is brought back into the dry dock. There are just 5 weeks to go before she sets sail again on the second sea trials. 5 weeks in which to investigate and correct the faults with the bow thruster door, examine the conditions of the pods and stabilizers after their rigorous testing, and continue with the fitting out and exterior and interior painting. Immediately, the liner fills up with 3,500 workers. One of the first priorities is to deal with the bow thruster door.
It's an incident that was not foreseen, and it's due to mechanical forces and hydrodynamic forces, which were probably not completely expected.
With the door lost at sea, a replacement is needed, but the Polish shipyard where they were manufactured cannot supply one in time. The shipyard decides that they will make the 3.5-ton replacement.
In a way, we are happy that it happened during the first sea trials, so we are sure that we deliver a ship we are confident with.
For most of the technical tests, the results from the first sea trials were better than expected. The pods held up well under maximum load, but the trials revealed a problem.
The cooling system of the pods were not functioning correctly during the first sea trial. So now we have done some modification this weekend, in fact.
The pod's electric motors are cooled by air. This air, in turn, is cooled by a secondary water system. The modification involved reversing the water flow in the secondary system of 3 of the pods. In the dry dock, the main diesels continue to be run both for testing and to provide electricity on board.
To cool the engines, huge volumes of water from the River Loire are circulated through the liner, then pumped out of the side and back into the river.
On the next sea trials, the speed test will be rerun. To reduce friction to a minimum, the bottom of the hull is rubbed down and painted again, and the propellers are polished and wrapped to protect them against any stray paint spray. All over the liner, painting continues, and areas such as the swimming pools still need to be completed. There is a sense of urgency to get the interior work finished, as the scaffolding will have to come down before the liner sets sail again. All too soon, the second set of sea trials are just a day away. Although the new bow thruster door is in place, now another problem has been identified.
There was some damage on some of the bearings on the bow thrusters. We therefore decided not to take any risks, and we're restricting the use of the bow thrusters to limiting them in their power.
The problem will be fixed after the trials. For the test, they'll run them at 50%.
It won't affect the delivery date because this can be done concurrently with everything else that's going on. It's not a serial effect.
Last-minute jobs are tackled, like repainting all the liner's identification. An army of workers prepare the liner for tomorrow's sea trials. Early morning sees the liner still a hive of activity. Tools and equipment have to be cleared out, but tons of materials must be brought on board as hundreds of workers will continue with fitting out work while the trials are going on. In chill autumn weather with a noticeable wind, the second sea trials begin. It is the shipyard's chance to retest the equipment that failed on the first sea trials, the pod's cooling system and the bow thrusters. It is also the opportunity to carry out important procedures such as the emergency crash stop and the engine endurance test. But the first priority is setting up the liner's state-of-the-art navigation system. The computerized system enables the captain to steer using a simple joystick, to hold a plotted course in autopilot, and with the dynamic positioning or DP system, maintain a fixed point at sea. With global satellite information coupled to the powerful onboard computer controlling the pods and thrusters, the DP acts as a virtual anchor. But first, the system must learn the liner's characteristics, how she reacts to different weather and sea conditions such as strong winds and tidal currents, a process that will take several days to get right. Now is also the time for the speed test to be rerun. Before the test, the sea condition must be agreed upon, as the wave height and currents have a bearing on the final speed computation.
It seems so much faster.
During the first sea trials, Queen Mary II reached her contractual top speed. But on these trials, everyone relished the chance to push her to the limit. Coming to a decision on the height of the waves involves negotiation between the shipyard's captain, Captain Warwick, and the other senior officers. Using their years of experience, they study the sea condition to reach a consensus.
The max is going to be 3.8, 3.9.
A significant wave height of 6.5 feet is agreed upon. Before the speed runs get underway, Stephen Payne takes bets on the likely outcome. And for the final run, Captain Warwick is invited to take the helm. For everyone involved in the construction of the ship, the speed she achieves is rewarding.
I've just come up from our daily morning meeting with the shipyard, and it would appear that the first tentative results from the speed trials we did last night was that the ship has achieved a speed of 29.63 knots.
While the engines and other hardware are put through their paces, elsewhere every moment is taken up with endless fitting out jobs. Carpet fitters work in the public areas, and painters carry on their work all around the liner. With only 700 on board, it's a good opportunity to get quietly ahead, and each job completed is one more step towards finishing her for the inaugural voyage with paying customers in 2 months' time. As the sun sets on the penultimate day of these trials, the liner must go through one of the most dramatic tests, the emergency crash stop.
We will prepare to the test by stabilizing the speed during 2 minutes. So that's why we will make half a turn now, because the wind is northeast at this moment. After 2 minutes, we'll give a top to start the crash stop maneuver. There will be a time recording and also a distance recording by the people over there.
But a wrong button's been pressed, causing one of the diesel engines to rev up to maximum.
Because we pressed this.
Nicholas suggests that to avoid delay while the engine is calming down, they proceed with the half-speed crash stop.
So half speed is 13.2 knots. Okay, the 2-minute period. Fin de la période de 2 minutes. Attention pour le crash stop. Stop.
The great liner comes to a stop, well within the specified distance. The second trials are almost at an end.
It's given us a good opportunity to have a good look round the ship, because if I was in command, I wouldn't be able to leave the bridge. So during the course of the trials, I think I've just about covered every single area of the ship. I haven't been up the funnel yet, but I'm planning to do that before we dock this afternoon.
Captain Warwick is part of a Cunard dynasty. For both he and his father, Commodore William Warwick, captained the Queen Elizabeth II. During 5 decades at sea, he has seen great changes. Gone is the ship's wheel, replaced by a joystick.
The control systems are unlike any others. We can turn this ship in its own length quite comfortably with the plant that we now have.
The traditional compass is replaced by satellite navigation, the rudder by steerable pods. Could Captain Warwick have imagined when he started his career at sea that he would end up master of the biggest liner in the world?
My very first ship was a ship belonging to the Port Line, and I joined her in 1958. She was barely 7,000 tons. This magnificent liner is over 150,000 tons. She had fixed propellers. We have a totally different propulsion plant that was undreamed of in those years. So it's quite a contrast, but one I'm very comfortable about.
After 4 days at sea, the liner enters the Loire estuary, the shipyard, delighted with her performance. Within hours of arriving, the dock will be drained again, and work will begin removing the bow thruster drive shafts for their return to the manufacturers in Sweden. But then, disaster strikes. On a family open day at the shipyard, a gangway gives way as a group of visitors board the liner. They plunge over 50 feet to the concrete dock below. 15 people die. More than 30 are injured. The yard and the town of Saint-Nazaire go into mourning.
The images of that day we will have forever. But you live with it. It's true that when we went back up, when we went across the ship's walkway, we couldn't stop thinking about it. But despite everything, we've got to finish the ship. And life carries on.
With heavy hearts, everyone returns to work. The bow thruster drives are removed and sent off by truck for refurbishment. This is a job that would normally take more than a month to complete, but the plan is to have the liner floating again in less than 3 weeks' time. It is a real race against the clock.
I would say that that job in a normal period, when we're doing the job long time before delivery, would take 1 month, and they did it in 1 week. They put all the means and manpower on this job because it was critical for the delivery.
With the delivery date just 3 short weeks away, the liner's 1,300 new crew members begin arriving in Saint-Nazaire for their intensive training programs. All the safety systems on board must be checked and then rechecked. If there were a fire in a huge space like the 1,300-seat Britannia restaurant, the extraction system must be capable of clearing the smoke in a specified time so that the exit signs are clearly visible. The extraction system is tested.
Guys, are you ready? Okay. Light up the bombs. Are you satisfied? Do you want more smoke anywhere? Or? Okay, start smoke extraction. What a job. From where we are, you see your exit sign. One there. One there. One there.
Another crucial safety area is the ability of the crew to help passengers to abandon ship in an emergency.
About to return to the hospital.
This drill is practiced over and over with every member of the crew given a specific role, and they will rehearse it until it becomes second nature.
We've had to put the whole crew through the drills. There are 7 crew members in charge of each boat. And then, of course, we have 1,300 crew on board who have all sorts of duties to do. So all of them are being put through all the safety training that they have to be put through to ensure that we can fight a fire, abandon the ship, and do everything as safely as possible.
The lifeboats must be filled with passengers and lowered 100 feet from deck 7 to the sea.
When we launch all the lifeboats and all the crews and all the crew who abandoned ship, there's always a few left over who are ensuring that everything is safe, and they have to get off the ship as well. And we have ladders on each side, but we also have a number of these descender units. And basically, for the last man on the ship who wants to get off, down to the boat, he'll strap himself on and launch himself off the boat deck down to the water.
With only 3 days to go before delivery, the emergency procedures have to be signed off by the MCA, the British Maritime Coast Guard Agency.
Particularly on a large passenger ship like this, where they're in charge of a large number of people, they have to demonstrate to us that they can actually cope with an emergency situation. If they don't come up to standard, then we cannot give them the passenger certificate until we are satisfied with their competence. And in the worst scenario, yes, the vessel would remain here until we were satisfied.
The great day is finally here. After almost 2 years of construction, the deadline is reached, and Queen Mary II sits peacefully in dock, ready to be formally handed over to her new owners. The MCA have given the liner her certificate to carry passengers, and her 1,300 newly trained crew are ready to go. Remaining hours, the finishing touches are given to the interior.
What we're going to do now is I'm going to call station numbers. This is station 1.
And the restaurant staff are briefed before they serve a farewell lunch.
Okay, start getting your butters on your table, get your creams and your milks in. Okay, I need to have you back here for 1:45.
Queen Mary II will sail out on the afternoon tide, but before that, at 12:30 on the top deck, the crew are invited to watch the lowering of the French flags and the raising of her new colors, the British Red Ensign. The finishing touches are still being given to the grand lobby as the pianist plays and the guests file into lunch. As the tide rises, the dock gates are open to let the tugs cluster around the liner.
We kindly ask all visitors, all contractors, and all persons who are not sailing on the Queen Mary II to leave the ship at this time. Thank you.
A few minutes after high tide at 3:30 p.m., Queen Mary II eases away from the dockside, her home for the last 7 months. In the freezing air, workers line the shipyard's quay to see her off, while thousands of sightseers wave from the banks of the Loire. As she turns her bow towards the sea, the French Air Force salute her leaving. She's heading for the Spanish port of Vigo for 2 days of maneuvers before the homecoming voyage to Southampton on England's south coast for her formal naming ceremony.
Well, she's now gone, and she's gone with a bit of our heart for sure. We spent 3 years working on drawings, on construction, on testing, commissioning, and now she's gone, so yeah, we feel a bit empty for sure.
In contrast to her departure from Saint-Nazaire, Queen Mary II's arrival in Southampton on the day after Christmas is marked by gale-force winds and driving rain. Despite the weather, a flotilla of small boats and thousands of well-wishers turn out to greet her as she enters the Solent and makes her way majestically up Southampton Water. The whistle that announces her presence was originally on the first Queen Mary. Now, reconditioned it once again, booms out across Southampton Water, the sound carrying for 10 miles. In the following days, the liner will leave its Southampton berth for a series of what are called shakedown cruises, short voyages with invited guests that enable the teams of chefs, waiters, cabin staff, and cleaners to streamline their service. At the beginning of each voyage, in the tradition of the great Cunard liners of the past, Captain Warwick welcomes his guests to a cocktail party in the Queen's room. For as well as his responsibilities commanding the liner, he also has numerous social duties. Three decks below in the laundry, the Chinese crew continue with the day and night task of cleaning and ironing the liner's mountain of dirty laundry.
There's nearly about 8,000-9,000 sheets, and maybe one day about 15,000 like tablecloth, 12 to 13,000 napkins. It's every day, yeah, that's every day.
In the kitchens of the Britannia restaurant, the chefs and waiters prepare for the first sitting of the evening. A vast quantity of food is served on the liner. She is, for instance, the world's largest consumer of caviar. And in her restaurants and bars, every day, over 1,000 bottles of wine are consumed. The service in this grand hotel on the sea must run as smoothly as her finely tuned propulsion and navigation systems. All that remains is the official naming of the liner. And for this, the full force of British maritime tradition swings into action. As with all great liners that sail under the British flag, the reigning monarch performs the naming ceremony.
I name the ship Queen Mary II. May God bless her and all who sail in her.
As she sets out across the ocean, she begins a long and arduous career. Over 40 years at sea, she will travel the equivalent of 12 times to the moon and back. And so a new queen of the North Atlantic begins her reign in the company of her proud and elegant predecessor, Queen Elizabeth II. And though in the future her size and capacity may be surpassed, Queen Mary II could well be the last purpose-built liner the world will ever see.